Hello, fellow nerds, welcome back. Okay, so we are still looking at functions, and we've talked about so many things. Yeah, we've talked about finding the domain, we've talked about finding the inverse of a function, we've also talked about how you can prove that a certain function is an inverse of a function. Okay, um, we haven't talked about finding the range. What do we understand by a range? So like we talked of the domain was possible values of x that will make a function defined. Now the range is just the opposite of the domain, so we are looking at the range, the possible values of y that will make the functions defined. Okay, so there are two main ways of finding the range. There might be others, but in these videos we're just going to focus on two ways. So okay, let's get into action. So a is our g of x equals to x plus 9 over 5. All right, how do we find the range of a function? So there are two ways. So the first one, what you do is, the way we find the inverse, you follow the same steps. So we'll let this equals to y. So y x plus 9 over 5. Okay, so that, and then you make x the subject of the formula. So x will be the subject of the formula, and we're going to have 5y. We should be pros by now with these things. So our x is going to be minus 9. So you are now going to find what possible values of y should we have for this to be defined. So you find to say any value. So you find to say any real number will be define this function. So our range is all real numbers. So you can say our range is negative infinity to infinity. So that's our range. Okay, what's the second method? The second method requires you graphing. So the second method, you should know how to graph these functions. So if you don't know yet how to graph, don't worry, there will be a video dedicated to that. So there will be a video talking of how you graph functions. So if you graph this function x over 5, this is the same as like this. So if we were to graph this, we're going to have something like this. This will shift, so this is our y. So our y will shift 9 over 5 going, so 9 over 5 is like 1.8. So it will shift 1.8 here. So our graph is simply going to be like this. So going down, it's going to look like that. So you find to say our range, so the range we said are the possible y values. So you know that this is the y-axis and this is the x-axis. So it's going to negative infinity up to infinity. So that's our range, negative infinity to infinity. That's the second method. So if you don't know how to graph, don't worry, there'll be a video dedicated to graphing. Okay, we'll move on to b. The cube root of x minus 1. The cube root of x minus 1. So b is the cube root. Okay, to be safe, let's just be using the same board. So Okay, we go to g of x is the cube root of x minus 1. So our first method, you make x the subject of the formula, so you should be pros when it comes to search by now, like I said. So what do we have? So you raise that to power 3, that will cancel. You're going to have something like x is equal to the power 3 plus 1. So you're going to have something like that. So what are the possible values of y? So you find, say, even this one is negative infinity to infinity. That will be our range. Okay, second method, we show by graphing. How is, so you have to understand that a graph of a cube root of a function, or a function the cube root, the graph is supposed to be like this, something like that. So how is this graph going to be like? So this is affecting x, so the graph is going to shift the negative side of x. So like I said, if you find graphing challenging, kindly comment and we'll make a video just based on graphing. So the graph is going to be like that. So it's going to shift to -1. Okay, let me just, no, I was never a fan of art. Yeah, I never found art interesting, but something like that. Okay, so you find to say this will continue going like that, and that will continue going. And so it will continue going to the positive side, and it will continue going to the negative side. So this will be negative infinity to infinity. Okay, that is another way. We move on. Interesting. So we move on to our C. F of x equals to x minus 3 over 2. X minus 3 over 2. So as usual, we make our x the subject of the formula. We're going to have something like that. Sorry. So it's going to be 2y plus 3. So what possible values? Negative infinity, comma infinity. So like that. We show by graph, the second method. So you know how to graph that. So that is, this function is the same as having x over 2 minus 3 over 2. So first of all, this function is going to shift 3 over 2 to the negative side. So it's going to shift to the negative 3 over 2. It's going to shift to the negative 3 over 2. And so this function is going to be like that. Okay, so we know that it will continue moving the infinity, positive and negative infinity. So the range is here. See, we are proving using two methods. Okay, it's up to you which one you find easier and which one is. So the first method is easy when you are taught to find the inverse, and also we are taught to find the domain, the inverse and the range of a function. Meaning, you, as you are finding the inverse, you're also going towards finding the range. But if you just have the range and the, but if you know how to graph it. Okay, so we move on to our f of x equals to 1 over x minus 1. Cool. As usual, y, what are we going to have? So we're going to have xy minus, so we're going to have xy minus y is equals to 1. So our function is going to be something like that, over y. Okay, so what's our range? Interesting. What's our range? So what values won't make this defined? So we know that this can't be 0. So it's any real number, but y should not be equal to 0. How can I write that in interval notation? So interval notation is going to be negative infinity, comma 0, I open union 0, comma infinity. Okay, just like that. We show by graphing. So that's how the graph is going to be like. That's how the graph is going to be like. And okay, we have that. Let's show how the graph is going to look like. So what is the graph of x? 1 over x. So we know that 1 over x should look something like this. Something like this. Okay, something like that. That should be our 1 over x. So we know that there is this negative 1 affecting our x. So what do we do? So this is just a sign that there is a shift. There's a shift towards negative 1, or it has shifted towards negative 1. So negative 1 is here. So there's a shift. So this will be like our, okay, so it has shifted. So instead of being on 0, it is moved this side. So it's like this. Okay, like that. Okay, and like that you have your range. So we know that our range will go up to positive infinity to continue going up. So this is how the graph is going to be. So know that our range will continue going down, and that will continue going up. So our range, except it won't touch this. It won't touch 0 here. It's not touching it. So you know that it is negative infinity, comma 0, union 0, comma infinity. And that's how you find the range. So you find to say, if you know how to graph the functions, you can find the range as well as the domain just using the graphs. And yeah, that's all you need to know about finding the range. So we've covered so far finding the range, the domain, the inverse, proving that the function is an inverse of a certain function. Yeah, we'll move on and look at many other things about functions. Okay, thank you very much. Share if you find this video to be helpful. Share with your friends and let them learn something as well. Thank you very much. See you in the next video.